Good day everyone. Here's our challenge for today. A square containing a quarter circle, a semicircle, and a circle. Now the question is, what is the length of the radius of this small circle, given that the side length of this square is equal to 10 units? Now if you want to try this problem, just pause this video right now. And if you're ready, here's the solution. And I hope you pause this video. Now let's answer this question together. To answer this question, what we're going to do is to use some concept. Now if we have two internally tangent circles, and we draw a tangent line to the point of tangency, and consider the point of tangency, the center of this small circle, and the center of this big circle. Now the three dots are said to be collinear. Why? Because if we draw the radius of this circle to the point of tangency, the radius and the tangent line are perpendicular to each other. It directly follows that the point of tangency and the centers of these circles are collinear. Now we will use this concept to answer this question. First thing to do, let's draw the tangent line of this small circle and this quarter circle like this. Now let's consider the point of tangency, the center of this small circle, and the center of this quarter circle. Now we know if we connect them, we create a straight line because these 3 points are collinear. Now from here, we label some segments. We know from the center up to the circle, we have the radius. Therefore, the measure of this small segment must be r. Now, take note that the radius of this quarter circle must be equal to 10. Therefore, this line segment here from this first dot to the second dot must be equal to 10 minus r, or the radius of the quarter circle minus the radius of the small circle. Next, draw the radius of the small circle directly to the side of the square. Now since the circle is tangent to the side of the square, it follows that the radius is perpendicular to the side of the square. Also, let's label this segment as r because it is also the radius of the circle. Now, consider this right triangle right here. Now, since it is a right triangle, we can now use the Pythagorean Theorem. So we have a squared plus b squared equals c squared. Substitute all the given values and we have this a represents r, the hypotenuse of this right triangle is 10 minus r, and the missing leg must be b squared. Now let's focus on this equation. We have r squared plus b squared equals 10 minus r quantity squared. Now, expand the right hand side. If we do that, 10 minus r quantity squared will give us 100 minus 20r plus r squared. Now, subtract r squared on both sides. Then we have b squared equals 100 minus 20r. Now, get the square root on both sides. We get that the value of b must be equal to the square root of 100 minus 20r. Now, let's go back to our figure. We know that the bottom part or the other leg of this right triangle must be square root of 100 minus 20r. Now, from here, let's focus on our diagram. What we're going to do now is to create a perpendicular line to the side of this square directly to the center of this small circle. Now take note that this line segment is perpendicular to the side of the square. Next, let's consider the center of this semicircle. Now since the diagonal of this semicircle is 10 units, it follows that the radius of the semicircle must be equal to 5. Now let's connect those centers like this and consider this right triangle. Now let's label some segments. If this is r, the opposite side must be also r. Now since the radius of this semicircle is 5, it follows that this segment is simply 5 minus r. Now, how about the hypotenuse of this right triangle? We have the radius of the semicircle, which is equal to 5, and we have the radius of the small circle, which is equal to r. Therefore, the length of this hypotenuse must be equal to 5 plus r. Now, since we have a right triangle, again, we can now use the Pythagorean theorem. We have a squared plus b squared equals c squared. At this point, a represents 5 minus r, b represents the square root of 100 minus 20r, and the hypotenuse, or c, is equal to 5 plus r. If we do that, we get 5 minus r quantity squared plus square root of 100 minus 20r quantity squared equals 5 plus r quantity squared. Now let's focus on this equation. Now from here, we can now cancel out immediately the square root and the squared. If we do that, we get 100 minus 20r. Now, let's expand 5 minus r raised to 2. If we do that, we get 25 minus 10r plus r squared. Now, let's expand the right-hand side. We have 5 plus r quantity squared. If we do that, we get 25 plus 10r plus r squared. Now, if we subtract 25 on both sides, we cancel out 25. And if we subtract r squared on both sides, we cancel out also r squared. In return, we have negative 10r plus 100 minus 20r equals 10r. Now, let's combine like terms. Negative 10r minus 20r will give us negative 30r. So, we have negative 30r plus 100 equals 10r. Now, add 30r on both sides, we get 100 equals 40r. Divide 40 on both sides, we have 100 over 40 equals r. Now simplify, divide the numerator and the denominator by 20. Therefore, we have 5 over 2. Therefore, the radius of the small circle must be equal to 5 over 2. And don't forget the unit. We have units. And as always, we're done.